Ever wondered how computers can find hidden patterns and group similar data without being explicitly taught? That's what we're delving into today with Module 3 of Demystify Tech. A warm welcome to all our viewers. We're on a journey of discovery, unraveling the mysteries of technology one module at a time. Today we turn our attention to the intriguing world of unsupervised learning. In this session, we'll explore the exciting realm of unsupervised learning, an essential aspect of machine learning, with insights specifically tailored for executives. Unsupervised learning is all about finding hidden structures in data without any predefined labels. Picture this: you're at a party where you know no one. You start mingling, noticing similarities and differences among people, forming groups based on shared interests or characteristics, all without knowing anyone's name. That's unsupervised learning in a nutshell. It's a crucial component of machine learning where algorithms discover patterns and relationships in data all on their own. Imagine a child sorting blocks by color or shape without being told what to do. That's the essence of unsupervised learning. The algorithm learns to discern patterns and categorize data without any prior instruction. In artificial intelligence, unsupervised learning is like the mysterious detective, sifting through heaps of data to unearth hidden correlations and patterns that might not be apparent to the human eye. It's like the Sherlock Holmes of AI, using its deductive skills to find clues and solve mysteries within the data. Unsupervised learning and supervised learning are two sides of the same coin, both vital for machine learning. However, the fundamental difference lies in the approach. While supervised learning is like a student learning from a teacher with a predefined syllabus, unsupervised learning is like a self-taught artist, exploring and creating without any set guidelines. That's how unsupervised learning differs from supervised learning. No predefined labels. It's about discovering the unknown, finding hidden gems in the vast universe of data. This uncharted territory is where the true power of AI lies. Two key components of unsupervised learning are clustering and dimensionality reduction. Let's start with clustering. Picture this: you have a pile of socks, all different colors and patterns. Clustering is like sorting your socks into piles based on their color and pattern, without any labels telling you where each sock should go. In the world of machine learning, clustering does the same thing. It groups similar data points together based on their characteristics. This is incredibly useful when we have a large amount of data and we want to find some structure or organization within it. Now onto dimensionality reduction. Imagine you're a chef with a recipe that has too many ingredients. It's complex and difficult to manage, but what if you could simplify that recipe, reducing the number of ingredients without losing the essence of the dish? That's what dimensionality reduction does with data. It simplifies complex data by reducing the number of features or ingredients, making it easier to analyze and understand. But how does this work? Well, it identifies the most important features that capture the essence of the data. Just like in our chef analogy, it identifies the key ingredients that make the dish what it is. It then discards the less important features, simplifying the data while preserving its core structure. You might be wondering, why is this important? Well, in today's data-driven world, we often deal with high-dimensional data. That's data with a lot of features. Analyzing this data in its original form can be like trying to find a needle in a haystack. Dimensionality reduction helps us simplify that haystack, making it easier to find the insights we're looking for. So in conclusion, clustering and dimensionality reduction are like the sorting and simplifying tools of unsupervised learning. They help us make sense of complex, unlabeled data, grouping similar data points together and reducing the complexity of the data. Through clustering and dimensionality reduction, unsupervised learning simplifies complex data and finds hidden patterns. Unsupervised learning has many real-life applications impacting executive decision-making. Let's dive into a few examples to illustrate how unsupervised learning is used in the real world. One of the most common applications is customer segmentation. In this scenario, unsupervised learning algorithms analyze customer data such as their purchasing habits, preferences, and demographics. The algorithms group customers with similar characteristics together, creating distinct segments. This allows businesses to tailor their marketing strategies to each segment, improving customer satisfaction and increasing sales. Another practical use of unsupervised learning is in the field of anomaly detection. This involves identifying unusual data points or patterns that deviate from the norm. It's like finding a needle in a haystack. For instance, in the finance sector, anomaly detection can be used to identify fraudulent transactions amongst millions of legitimate ones. Similarly, in network security, it can help detect unauthorized access or potential cyber threats. Moreover, unsupervised learning is crucial in data compression. By reducing the dimensionality of data, unsupervised learning helps to simplify complex data sets, making them easier to store and process. This is particularly important in industries dealing with massive amounts of data, such as healthcare, where medical imaging data needs to be efficiently stored and analyzed. Furthermore, unsupervised learning is a cornerstone of recommendation systems, which are everywhere today. Whether it's Netflix suggesting a movie you might like, Amazon recommending a product, or Spotify curating a personalized playlist, these are all powered by unsupervised learning. These systems analyze your behavior and preferences along with those of similar users to make personalized recommendations. Lastly, unsupervised learning is used in social network analysis, where it helps to identify communities within the network. This could be used for targeted advertising, or even in epidemiology, to understand how diseases might spread within a community. From recommendation systems to anomaly detection, unsupervised learning is a powerful tool in data analysis. For leaders, understanding unsupervised learning is crucial. This powerful tool is like a secret weapon, capable of unlocking hidden treasures in your data. Imagine being able to sift through mountains of data and find patterns that can help drive strategic decisions. That's the power of unsupervised learning. Consider the potential for optimizing customer experiences. By grouping customers based on their behaviors, preferences, and needs, you can deliver personalized experiences that resonate. Imagine the satisfaction of your customers when they feel seen and understood. That's customer loyalty in the making. And let's not forget about innovation. Unsupervised learning can reveal new pathways, new ideas, and new opportunities. It can help find connections that weren't apparent before, sparking fresh perspectives and leading to innovative solutions. In essence, unsupervised learning is a tool that can help executives navigate the complexities of today's data-driven world. By leveraging unsupervised learning, executives can make informed decisions and drive innovation. Today we've unraveled the world of unsupervised learning. We've dived into how computers find hidden patterns, understood the concepts of clustering and dimensionality reduction, and seen its real-life applications. We've also discussed how this knowledge can enhance decision-making for executives. But that's not all. In the next module, we'll delve deeper, exploring the practical applications of AI and data-driven strategies. There's a lot more to discover in the fascinating world of machine learning. Stay tuned.